Assalamualaikum. My name is Muhammad Hazib bin Amran and we are from Group 1 Solid Mechanics and Simulation. My group member is Muhammad Khairul Anwar bin Muhammad Faris and Muhammad Afif bin Muhammad Saleh. We will present about finite element analysis study on glass fiber reinforcement epoxy GRE pipe used in oil and gas industry. So this is the real world problem. The requirement to describe and comprehend the engineering performance of GRE pipes become more crucial as applications spread widely. Thus, better understanding of the performance of glass fiber reinforcement epoxy GRE pipe also needs to be considered due to the improvement of the material for oil and gas industry pipes, as GRE has been considered as an alternative to carbon steel.
Hi, Assalamualaikum. So we continue about the objective of our group project. So first, objective is to analyze the tensile strength of glass fiber reinforced epoxy with carbon steel pipe. Then our second objective is to compare the result of glass fiber reinforced epoxy with the carbon steel pipe. Then we go to the method of assessment. So for the method of assessment, the mixture of glass fiber reinforced epoxy is 70% E-glass type as a fiber, then 30% epoxy as a resin. Then ANSYS Workbench 2023 software will be used as an analysis tool in this group project to analyze the tensile strength for the both pipe. Then the boundary condition has been set as a fix at one side, then the other side we will apply a 300 kN force. Then for the geometry has been set in this analysis as shown in this table. So the geometry for both pipes, so the outer diameter is 323.9 mm and the nominal diameter is 300. Wall thickness schedule is 9.53 mm, inner diameter 290.47 mm. Then the pipe wall thickness is 33.43 mm. So how we get this geometry? Let me explain in the explanation of pipe size. So to get the inner diameter, actually the nominal pipe size needs to be minus by wall thickness schedule from the pipe size chart. So this actually work at actual experiment during oil and gas industry. So here I take as an example 2-inch pipe. So for the 2-inch pipe, the nominal diameter here is 50 mm. Then the outer diameter is 60.3 mm. So we can see from the here, I take schedule standard as an example here. So from the chart, we see the schedule standard and the 2-inch row. We can see the wall thickness schedule is 3.91 mm. So if we want to get the inner diameter, we need to minus the nominal, which is 50 mm, minus by 3.91 mm. Then we get the inner diameter. So therefore that's the way that we get the geometry for this project. So that's all from me. Continue with my friends. Thank you.
For result in discussion, tensile strength has been conducted by using a structural system. Fixed support at point A and 300 kN force has been applied at point B. For total deformation, the total deformation of Campbell steel pipe is 0.0873 mm, while GRE can achieve 0.3569 mm of deformation. For equivalent elastic strain, carbon steel can reach 0.00001 and GRE can reach 0.00043. For equivalent von Mises, the equivalent von Mises stress show that the carbon steel is slightly higher than GRE, which is 22.14 megapascal for carbon steel and 20.66 megapascal for GRE pipes.
In conclusion, the results show that carbon steel just has slightly higher stress compared to GRE, which means it shows that GRE can hold the same stress as carbon steel during this analysis. Furthermore, the outcome also shows that GRE can deform longer than carbon steel with the same stress. GRE and carbon steel have their own strength, which means it depends on the application or situation whether to choose the GRE or carbon steel as the pipe material. Based on the analysis result, it shows that GRE can be an alternative to carbon steel used for oil and gas industry pipe in terms of strength. For recommendation, the result that have been gained in this study can be validated by conducting an experiment. Another type of analysis can be conducted that is related, such as thermal expansion analysis, hydrostatic analysis, contraction analysis, or friction flow analysis. Different geometry can be also used for the analysis to see whether the outcome are still the same or change compared with this analysis. So that's all from our group. Thank you.